Hello there, and welcome to Science Reshaped, a quiet corner of the universe where your thoughts can rest and knowledge becomes a calm lullaby for the night. At this very moment, a photon that left the first stars over 13 billion years ago might be entering your eye. For that photon, not a single instant has passed. Its departure and its arrival exist as one continuous moment. Yet for us, it carries the long memory of the universe's journey, crossing galaxies, curving around gravity's pull, stretched by the slow widening of space, only to arrive here with you in this silent moment. Tonight's soft exploration is about light. Not merely the glow of your bedside lamp or the shimmer of a candle's flame, but the timeless traveler that threads all of history together. We will trace a single photon across the ages, from the dense fog of the early universe to the first clear openness of recombination, through the dark quiet between stars, past the birth of the first suns, through the bending of gravity, and into that strange realm where waves and particles blend. Before we begin, I'd love if you could take a moment to like this video and subscribe to Science Reshaped. Only if these calm cosmic journeys bring you peace. And when you're ready, tell me in the comments where in the world you're listening from and what time it is for you. It's always wonderful to see where everyone gathers from, each of us resting in our own little corner of time. Now, dim your lights if you wish, maybe turn on a soft fan for background hum. Let yourself relax, and we'll start our gentle voyage into the story of light together. If your thoughts begin to drift, that's perfectly fine. Let them wander. We'll still be here, quietly unfolding the tale. If I were to ask you to imagine light, you might first think of something completely familiar. The golden edge of sunrise sliding through your curtains, the steady glow of a desk lamp, or the cold white gleam of your phone screen flickering awake in the early morning. Light is woven into your day so seamlessly that you almost never notice it. It guides your steps in darkness, softens the shadows around your room, and glitters across the surface of a glass of water. We rarely stop to think about it. Yet, light is the medium through which almost everything becomes visible. It is the messenger that allows the world to appear before us, and beneath its simple presence, light is deeply mysterious. It does not age as we do. It never slows or stops. It is both a wave spreading outward and a single particle knocking softly at your door. It is the warmth you feel on your skin and the colors bending through a rainbow, the signal inside a fiber optic line, and the gleam of a distant star thousands of light years away. We often treat light as a simple fact of existence, but in truth, it is one of the universe's most astonishing forces. Think of how easily we accept it. You flick a switch and the bulb blooms. You open the window and the morning flows in. Yet every time this happens, you are part of something rooted in the very structure of reality itself. When that light reaches your eyes, it travels at a constant speed, a speed no object made of matter can ever match. The speed that defines the balance of space and time. To you, it seems to cross the room in an instant. But if you could somehow move alongside it, there would be no journey at all, only the eternal instant of arrival. You might remember sitting near a window as the sun slowly sank. The room cooled, shadows stretched, and the light turned from white to amber, then faded into a deep blue. During all those moments, beams of sunlight had traveled for 8 minutes across empty space to reach you. In that time, Earth turned a little. Your thoughts wandered. Maybe you lifted a cup, took a sip, or checked your phone. But for those photons, those tiny packets of light, that journey from the sun to your window did not take 8 minutes. It did not take any time at all. For them, emission and arrival are bound into one single instant. This is one of light's strangest truths. From its own impossible point of view, a photon never grows old. And yet, while light itself is untouched by time, it carries time within it. The color of starlight reveals how quickly the universe stretches, how far a galaxy lies, and what elements burn inside its stars. Light is the perfect courier, recording everything without effort. Every photon is a quiet historian whispering about where it began. And the most remarkable part is that you don't need a telescope to witness this story. The glow from your screen, the flicker of a candle, they are the same phenomenon. Each photon is born flying at the speed limit of the cosmos and ends its long journey inside your eyes. Think about the last time you stood outside at night and looked toward the stars. The lights that shimmered above you were not there in any present sense. Many of those photons left their stars hundreds or even thousands of years ago. Some began their journey when the earliest civilizations were pressing symbols into clay tablets. They have been traveling ever since, unbroken, unhindered, until they softly reached your eyes. What you witnessed wasn't the star as it exists now, but as it once was long ago. To gaze at the night sky is to peer backward through time. Light is the bridge that makes this kind of time travel ordinary, available to anyone willing to look up. Yet we rarely pause to appreciate that miracle. Perhaps it's because light never calls attention to itself. It doesn't shout or demand notice. It simply reveals everything else. It slips into our routines quietly, brightening faces, glinting on streets, tracing the edges of glass, glimmering on raindrops, sketching a shadow along a wall. It is so steady and dependable that we forget it even exists. But when we finally take a moment to notice, the strangeness of it becomes impossible to ignore. You realize that this ever-present glow, this ordinary radiance, is also the foundation of relativity, the backdrop of cosmic history, and the silent storyteller of the entire universe. So tonight, as we begin our long journey through the story of light, remember, you are already surrounded by it. Light is not just an idea from a science book. It lies on your pillow, spreads across your floor, reflects inside your eyes. It links you to the sunrise 8 minutes away, to stars shining from millennia in the past, and to the first faint light of the newborn universe. Light beside you, light within you, light across all of time. If there's one quality that makes light more mysterious than almost anything else in the cosmos, it is its connection to time itself. Picture a runner circling a track. With every lap, seconds pass, muscles tire, and eventually the race ends. Now imagine another kind of traveler. One that never slows, never weakens, and in a sense, never experiences the race at all. That is what a photon is like. From the instant it is released, whether from the heart of a star or the faint glow of an atom, it moves at the ultimate speed limit, the speed of light. While we, standing still on the sidelines of the universe, measure its trip in minutes, centuries, or billions of years. For the photon, there is no passage of time at all. It is born and it arrives in a single seamless moment. Einstein's theory of relativity tells us why. Time behaves differently depending on how fast something moves. For us, moving slowly compared to cosmic scales, seconds tick normally on our clocks. But for an astronaut racing near light speed, those seconds would stretch. A lifetime on Earth could pass in what feels like only a few years to them. And at light speed itself, time as we understand it simply stops flowing. The kind of time a traveler carries personally, what physicists call proper time, becomes zero. A photon does not accumulate age. There is no before or after. Only emission and arrival joined as one. But we have to acknowledge one important limit. Physics reminds us that there's no proper rest frame for a photon. We can't truly imagine being the photon itself, because the equations that describe the universe stop making sense if we try to ride along at that speed. Still, the math lets us glimpse enough to see the outline of the truth. Light is timeless. And in that timeless state, it becomes the perfect courier of the cosmos. Picture sunlight landing on your hand through a window. It left the surface of the sun about 8 minutes earlier, crossed 93 million miles of vacuum, passed through the tug of planets and the curve of Earth's air, and finally, warmed your skin. To you, that's a short delay, the time it takes for light to reach you. But for the photons, there was no delay at all. Their start and their end are a single event. No matter how far they travel, whether from the sun or a distant galaxy, in their own frame, they were emitted and received in the same instant. The same is true of starlight. When you look at a faint blue point from a far-off galaxy, you are seeing photons that began their journey millions of years ago. Dinosaurs roamed the planet when some of those beams first set out. Civilizations rose and fell while they moved through space. And yet when they strike your eyes tonight, they're as fresh as the moment they began. Light is a messenger that never grows old, never carries fatigue, yet delivers its story perfectly intact across time and space. It's strange to realize that because of this, the universe is filled with instantaneous bridges. Every photon that reaches us isn't only a messenger, it's a window into the past. We never see galaxies as they are. We see them as they were when their light departed. To look far away is to look long ago. That single photon has preserved a snapshot across billions of years without ever experiencing any of them. Einstein himself was fascinated by this. As a young clerk in the Swiss patent office, he often imagined what it would feel like to chase a beam of light, to run alongside it and watch what happened. Would the wave stand still? Would it freeze before his eyes? That simple daydream led him to special relativity, the theory that forever changed our understanding of time and space. It all began with light's strangeness and the realization that its constancy demanded an entirely new view of reality. We might not picture ourselves racing beside photons on an afternoon walk, but the same wonder surrounds us constantly. Every time a lamp turns on, every time your phone glows, photons race toward you with this same timeless quality. They may appear ordinary, yet each one carries a piece of the deepest truth in physics. It's worth pausing to think about what this timelessness means for the idea of memory. We think of memory as fragile, fading with years. Photons, however, seem built of memory itself. Their color, wavelength, and the smallest shifts within them all record where they came from and what they passed along the way. A photon stretched by the universe's expansion contains the record of that stretching. A photon bent by a galaxy's gravity holds the signature of that gravity. A photon absorbed and released by an atom carries the fingerprint of that atom's energy. Each one is like an archive, as if the universe chose light to be its perfect librarian. And yet that librarian keeps no clock. Its shelves of memory are endless, but the photon itself never ticks a second. The difference between us and light is what makes this story so powerful. We live inside time, measured by seconds, days, and years. Light moves outside of it, preserving those same years for us to glimpse when it finally arrives. So the next time sunlight spreads across your floor, or headlights gleam on a rainy street, remember, those photons are not travelers aged by distance. They are timeless messengers, carrying snapshots of their origins, arriving fresh no matter how far they've come. Light may seem ordinary enough to read a page by, but it quietly holds the secret of the universe's timelessness within its glow. To truly understand light, we must journey far into the past, so far back that no stars had yet burned, no galaxies had yet taken shape, no planets had yet formed, not even the calm, cool atoms we know today. The universe in its earliest age was nothing like the one we see now. Imagine a cosmos, not dark, but blazing, filled with a restless ocean of particles, each of them hot and in constant motion. Photons existed then, but they were not free the way we think of them now. They were caught in a ceaseless crowd, colliding, scattering, and bouncing from one particle to another, like dancers in a frantic ballroom where no one could ever find the exit. During those first hundreds of thousands of years, the universe was more like a blinding fog than an open sky. Picture standing in the thickest mist you've ever seen. Maybe on a cold morning when clouds have settled to the ground. Then multiply that density beyond imagination. But instead of water droplets, fill the air with charged particles, electrons and protons too hot to bond into atoms. In such chaos, light could travel only a tiny distance before being scattered again. It couldn't stream freely. It jittered and ricocheted endlessly. Physicists call this state a plasma, a soup of free-moving particles where electrons and nuclei remain apart, unable to settle into calm neutral atoms. In a plasma, electrical charges drift constantly, and light interacts with them every moment. For a photon, this was like being lost in an infinite maze of mirrors, every step forward interrupted by another reflection. There was no transparency, no open path, no escape. If we could have existed then and somehow opened our eyes, we would have seen nothing of galaxies or stars. We would have been blinded by the brilliance of that glowing fog, unable to see beyond the nearest scatter. But the universe does not stay still. As it expanded, it cooled, just as steam cools into mist and mist condenses into water. Over time, the temperature dropped enough for protons and electrons to finally join together, forming neutral hydrogen atoms. That moment, hundreds of thousands of years after the Big Bang, changed everything. The fog began to thin, collisions slowed, photons that had been trapped suddenly found the universe opening before them. This event is known as recombination. The term can be misleading because there was no earlier combination. The particles had always been separate in the hot plasma, but now, for the first time, they united, and the effect was dramatic. Photons were no longer constantly scattered by free electrons. They could move almost unhindered, gliding through space like birds finally released from their cage. Imagine standing in a room so thick with smoke you can't see your hand. And then, in an instant, a breeze clears it all away, revealing the walls and open air. That is what happened on the grandest possible scale. The universe shifted from opaque to transparent. The fog that once imprisoned light vanished, and suddenly photons could begin their great journey outward. Many of those ancient photons are still traveling today. We know them as the cosmic microwave background, the faint, cool afterglow that fills space in every direction. If you ever tuned an old television to an empty channel, part of the static you saw came from those very photons, still humming across the cosmos nearly 14 billion years later. They are relics, fossils made not of stone but of light, carrying the imprint of that first great clearing. To call them fossils isn't poetic exaggeration. Just as shells or bones in rock preserve traces of vanished life, these photons preserve the record of the universe when it was only a few 100,000 years old, an infant compared to its current age. Tiny, ripples in their glow, slight variations in temperature and density are like fingerprints of the early patterns that would one day grow into galaxies, stars, and planets. Astronomers study these faint fluctuations using telescopes tuned to microwaves, reading them the way historians read ancient manuscripts. In those delicate variations lies the first visible chapter of cosmic history, the first story we can see written in light itself. In that early fog, and in the moment it lifted, lies one of the most profound transformations in the history of the cosmos. Before recombination, photons existed but were caged, their messages muffled before they could be heard. Afterward, they became the universe's first true messengers, free to carry information across unimaginable distances. It was the turning point, the moment the universe allowed light to become what it remains today, the courier of memory, the bridge through time. It's humbling to realize that the light in your room, the glow from your screen, the sunlight through your window, all are descendants of those first liberated photons. Without that ancient clearing, without the expansion and cooling that made transparency possible, there would be no visible universe, no starlight to guide our eyes, no galaxies to map, no quiet photons entering your gaze tonight. So when we speak of the universe becoming transparent, we're not just describing a physical change, we're describing the beginning of visibility itself. Before that transformation, the cosmos was hidden even from its own light. After it, the universe could finally see itself and tell its story through the timeless messengers that still travel toward us. When the fog of the early universe finally cleared, something extraordinary occurred. The cosmos became visible, not to us because humanity would not exist for billions of years, but to itself. It was as if the lights had risen on a stage that had, until then, been filled with sound and motion but no sight. Suddenly, photons were free. They streamed outward in every direction, no longer trapped by constant collisions with wandering electrons. For the first time, light could travel freely without being stopped at every step. That moment marked the beginning of cosmic transparency. The event known as recombination unfolded roughly 380,000 years after the Big Bang. It may sound like a long delay, but compared to the nearly 14 billion years that followed, it was only the blink of an eye. If the universe's entire life were compressed into a single calendar year, recombination would have occurred before the first week of January had ended. Everything else, stars, galaxies, planets, and even you listening now, would come much later. Yet that early clearing was essential. Without it, the cosmos would have remained a blinding plasma, with no way for structures to form or for future observers to ever glimpse the past. The light released during that moment never faded away. It's still here. We call it the cosmic microwave background, or CMB. Imagine a faint, ever-present afterglow filling the entire sky, stretched now into long microwaves by the expansion of space. You can't see it with your eyes, but it washes over you constantly, invisible and soft, like a ghostly warmth left behind by a fire long extinguished. When scientists first detected it in the 1960s, they assumed the noise was just interference, maybe pigeon droppings on their antenna, but no amount of cleaning could remove the signal. It was everywhere, uniform and constant, whispering the same ancient message from every direction in the sky. What they had stumbled upon was the fossil light of creation itself, the direct remnant from the moment the universe first became transparent. If you could step into a time machine and arrive just before recombination, you'd be blinded instantly. The haze of free electrons would scatter every photon in all directions. But only a heartbeat later, when those electrons joined protons to form neutral hydrogen, that blinding fog would dissolve into clarity. It would be like standing on a mountaintop as a storm suddenly clears, the clouds splitting apart to reveal a brilliant blue sky. The light doesn't vanish, it streams freely. And astonishingly, that same light has not disappeared with time. It has stretched, cooled, and dimmed, yet it remains, patient and enduring, still flowing through space and through you. Astronomers use satellites like COBA, WMAP, and Planck to measure this ancient glow with exquisite precision. What they see isn't just a uniform wash of light. It's a tapestry of tiny ripples, subtle fluctuations in temperature and density. Those ripples are the seeds of everything that would follow. Galaxies, clusters, filaments, the great cosmic web. They are written into the CMB like delicate brushstrokes across the oldest canvas in existence. When you look at a map of the cosmic microwave background, you are gazing at a portrait of the universe as a newborn, still wrapped in its first blanket of light. There's something deeply moving about realizing that this ancient glow still reaches us today. These photons have crossed all of time to arrive here, carrying the memory of their origin to our instruments and our understanding. They are not echoes that fade into silence. They are survivors, still vibrant, still speaking of their birth. Every telescope tuned to the right frequency is like an ear pressed to the cradle of the cosmos, listening to its first cry. In everyday life, you may have brushed against this glow without realizing it. On old television sets, when a channel wasn't tuned properly, some of the snowy static on the screen came from that very ancient light. Hidden among the noise, you were seeing photons that began their journey nearly 14 billion years ago. It's almost funny to think that the universe's first grand message ended up flickering in living rooms across the world, mistaken for background noise while people adjusted antennas. Yet that's the nature of light, always present, rarely demanding attention, but filled with meaning when we stop to notice. That transition to transparency wasn't just a change in visibility. It was the beginning of history itself. At least the part we can study. Before recombination, the universe left no direct record. The plasma erased everything that came before. But once light could travel freely, the story became visible. From that point onward, photons carried information across space. And much later, we learned to capture them. In that sense, the cosmic microwave background is the universe's diary. Entry number 1, the first written line in a story still unfolding. And what a record it is. By studying the CMB, scientists can calculate the age of the universe, its balance of matter and energy, even clues about its shape and destiny. The details are faint, written in the softest ink, but they can still be read by careful eyes. It's as though the cosmos, in its very first clear breath, left behind a note about itself, a quiet message tucked safely into the light that has traveled ever since. That first moment of transparency wasn't only a physical shift, it was a philosophical one. It reminds us that clarity often takes time. Sometimes, the most enduring stories appear only after the fog has lifted and the messengers have been released. Those first photons, freed in the universe's infancy, are still streaming past you right now, silent, timeless, and faithful, carrying with them the very first visible memory of everything that was yet to come. Once the universe became transparent, light could finally stretch its wings and move freely, but the story didn't instantly fill with stars and galaxies. After recombination, after that great clearing of cosmic fog, the universe entered a long, silent phase that astronomers call the Dark Ages. The name sounds ominous, but it simply describes what was happening. The cosmos was filled with light, yes, but there were no new sources of it yet. The first stars had not yet ignited. No galaxies shimmered in clusters. No quasars burned with brilliance. Only thin clouds of hydrogen and helium drifted through the vastness, slowly cooling as space continued to expand. Imagine standing inside a massive cathedral at night. its ceiling stretching high above you, its vast structure surrounding you. But with every candle extinguished, the architecture exists, immense and silent but unlit, waiting for the first spark. That was the universe during this period. The photons released at recombination were still traveling in every direction, carrying the record of the first clearing. But the cosmos itself was profoundly quiet. Those ancient photons were not idle. They kept moving, and as space expanded, their wavelength stretched. What had begun as a brilliant glare softened into longer, cooler tones, like a musical note drawn out until it becomes a low hum. This process is called cosmological redshift. As the very fabric of space expands, it stretches the waves of light traveling through it, lengthening their wavelength and lowering their energy. The photons don't slow down and they always move at light speed, but their song changes, reshaped by the growth of the universe itself. If you've ever stretched a rubber band, you know how it thins as it lengthens, the tension spreading out. Something similar happens to light. Photons aren't objects that can be stretched physically, but their wavelengths, their measure of energy, expand along with space. This means the color of light holds within it a record of distance and age. The farther that light has traveled, the more the universe has expanded during its journey, and the redder it appears to us. In that way, every photon carries not just a story of where it began, but also how much the universe has grown since. During the Dark Ages, the photons that we now detect as the cosmic microwave background were slowly stretched into longer and cooler wavelengths. What had once been a blinding glare became a soft bath of microwaves. If you could somehow drift through that early cosmos, you would still see the faint glow of recombination around you. But dimmer, redder, fading with each passing eon. Light was still traveling, still moving through the void, but muted, waiting for something new to accompany it. This quiet era lasted for hundreds of millions of years. It may sound like emptiness, but it was actually a time of preparation. Gravity was at work beneath the silence, pulling gently on the clouds of hydrogen and helium, drawing them together into denser regions. These invisible gatherings were the seeds of the first galaxies. The universe, though dark to the eye, was busy shaping its future. It was like the long night before a celebration. You know the dawn will come. But for now, the stage is still being set. The stars, the lanterns of the universe, had not yet lit, but the structures that would cradle them were forming. The photons continued their timeless voyage, gliding through this unseen architecture. They don't experience time, so the hundreds of millions of years between recombination and the first stars meant nothing to them. To a photon, that entire stretch was a single unbroken moment. We can't observe this age directly. There was little for light to illuminate, no stars to reflect from, no galaxies to shine. Instead, scientists infer what happened by studying the traces left in the cosmic microwave background and by simulating how matter behaved under gravity's slow pull. It's like trying to reconstruct the quiet hours before sunrise by studying the dew on the grass. The evidence is faint, but enough to reveal the outlines of what occurred. The universe was in waiting, silent, but not idle, filled with photons gliding endlessly through a starless expanse. There's something haunting and beautiful about that idea. Light existed, yet the universe was dark. Messages were traveling, yet there was nothing new to send. It was a pause between chapters, a silence heavy with potential. And for the photons themselves, of course, there was no waiting. They didn't mark those hundreds of millions of years. They simply moved, carrying with them the conditions of the universe as it slowly changed. To them, the Dark Ages were no different from any other instant. That part of the story reminds us that light isn't only about brilliance or spectacle. Sometimes it's about persistence, about quiet continuation, even when nothing seems to change. The photons streamed through the vastness, stretched thinner and thinner, waiting for the moment when the universe would finally strike its first match. And that moment would come. When it did, the stillness of the Dark Ages would give way to the dawn of starlight, and the universe would begin to shine again. After hundreds of millions of years of stillness, when the universe was filled with hydrogen and helium gas but no stars yet burned, gravity finally gathered enough matter to spark the cosmos's first true lights. This change didn't happen suddenly in human terms. It unfolded gradually across enormous stretches of time. but compared to the silence that came before, it was as dramatic as striking a single match in a cavern of darkness. The Dark Ages ended when the first stars were born. These pioneers of light were nothing like our gentle sun. They were vast, far larger than anything we see today, and they burned with staggering brightness. Composed almost entirely of hydrogen and helium, they lacked the heavier elements that later generations of stars would inherit, the elements that would one day form planets, oceans, and life itself. They were raw, massive, and short-lived. In only a few million years, an instant on cosmic scales, they consumed their fuel and collapsed, many exploding as spectacular supernovae. But during their brief lives, they shone intensely enough to carve glowing pockets of clarity in the surrounding hydrogen fog. Astronomers call this age reionization. The word may sound technical, but the picture is clear. Imagine the universe as a vast field of cool mist. Into that quiet haze, sparks flare, brilliant stars whose radiation tears the hydrogen atoms around them apart, splitting them back into protons and electrons. These glowing bubbles of ionized gas grew outward like lanterns spreading through fog until they began to overlap. And once again the universe turned transparent, not only for the ancient photons of the cosmic microwave background, but also for this new starlight. These first cosmic lanterns did more than illuminate, they transformed. When these enormous stars died in fiery explosions, they scattered heavy elements such as carbon, oxygen, and iron into the space around them. Those ingredients became the foundation for the next generations of stars, and eventually, for planets. Without those first giants, there would be no rocky worlds, no seas, and no living beings. The atoms in your body were forged in stars descended from those first beacons. It's difficult to grasp how extraordinary those stars were. They may have been hundreds of times more massive than our sun, shining thousands of times brighter. If you could stand on a world orbiting one, the light would be so intense that our sun would seem like a candle by comparison. But you wouldn't stand there for long. Such stars were too violent and unstable for planets to survive nearby. Their purpose wasn't to nurture but to transform, to open the next act in the cosmic story, for the photons that had been freed long before, during recombination. This new chapter changed little. They continued to drift along their ancient routes, mostly unaffected by the fireworks of the newborn stars. Some were absorbed or scattered, but most simply glided on, untouched, through the new bubbles of ionized gas. The cosmic microwave background remained what it had always been, a sea of ancient light stretched thinner and cooler by the expansion of space. But alongside that old afterglow, something new now shimmered. Fresh starlight, born in the first nuclear furnaces of the cosmos. If the universe had once been a silent stage, lit only by a faint afterglow, it now had its first performers, each holding a blazing torch. The darkness was broken not by a whisper, but by fire. When we look deep into the universe with powerful telescopes, we are searching for traces of that era. The Hubble Space Telescope, and now the James Webb Space Telescope, are designed to detect the dim light from those earliest galaxies. Their glow stretched into the infrared after billions of years of travel. What these instruments capture are faint smudges, small, hazy patches of light that might seem unimpressive to the eye, but each one is a relic from the dawn of creation. They are the first clusters of stars, shining across more than 13 billion years to reach us. Every photon that touches our detectors from those distant galaxies is a survivor of that earliest morning, a messenger from the time when darkness finally lifted. Think about what that means. Right now, as you listen, photons might be entering your eyes that left their homes when the first stars burned. To them, no time has passed. Their journey was instantaneous from their own frame of reference. To you, their story spans billions of years. But for them, it was a single, timeless moment of arrival. Light is not just a courier of physics, it is a carrier of ancestry. It connects you to the first dawns, to the first chemistry, to the first beacons that made your existence possible. There's a poetic symmetry in that. The universe began in blinding fire, cooled into silence, then gathered itself during the long hush of the Dark Ages, only to awaken once more in a blaze of new light. It's as though the cosmos needed that long pause, a deep breath before exhaling brilliance again. And in that breath, Everything we know was made possible. So when you gaze at the night sky filled with stars, remember, beneath those familiar points of light lies a hidden lineage. The stars you see are descendants of those colossal, short-lived pioneers. Their brilliance ended the darkness, and their ashes seeded the worlds to come. We are, in the most literal sense, children of those first lights, built from the elements they forged and scattered into space. Their glow was brief, but its echo will never fade. When the first stars ignited and the earliest galaxies began to form, the universe started to look more like the one we know today, though still raw and restless. Gravity gathered matter into swirling clusters, spinning clouds, and vast webs of gas and dark matter. These gatherings collided, merged, and evolved into the grand spirals and elliptical galaxies that now populate the cosmos. Each of those galaxies became a factory for light, filled with stars at different stages of their lives, each burning, shining, and dying in its own way. Some stars collapsed into neutron cores, others into black holes, and others scattered their material into the interstellar medium, seeding the next generation. The rhythm of creation and destruction had begun, and the universe grew richer with every cycle. But even as new lights filled the sky, the ancient photons from the earliest times still continued their journey. They passed through these evolving structures, curving slightly as they encountered massive objects. Gravity doesn't just pull on matter, it bends light as well. This phenomenon, called gravitational lensing, is one of Einstein's most elegant predictions. According to general relativity, mass curves space-time itself, and light follows that curvature. When a beam of light from a distant galaxy passes near another massive galaxy or cluster on its way to us, the path bends, like a river flowing around a rock. Sometimes that bending creates beautiful distortions, arcs, rings, and mirrored images of the same object. The light itself remains unchanged, but its route is stretched and twisted. Each lensed photon tells us something about both the object it came from and the one it passed by. If you imagine the universe as a vast hall of mirrors, gravitational lensing is what creates its shimmering reflections. Light takes multiple paths to reach us, delayed and curved, yet always constant in speed. Some photons travel directly, while others loop around invisible masses, all converging in our telescopes, each one carrying a slightly different version of the same ancient story. This bending of light has become one of astronomy's most powerful tools. By observing how starlight curves around galaxies and clusters, scientists can map the unseen matter that causes the distortion. Much of that matter is dark, invisible to telescopes, yet making up most of the universe's mass. In this way, light not only illuminates what we can see, but also reveals what we cannot. It acts as both painter and detective, sketching the visible world and hinting at the hidden structures beneath it. And as light travels across billions of years, its wavelength stretches further and further. Photons that left the first galaxies when the cosmos was young have been lengthened by the expansion of space itself. What once shone as brilliant ultraviolet is now seen as faint infrared. The universe in its growth has taken the light of its youth and deepened it into a cosmic red memory. Think of it like sound echoing through a vast canyon. The further it travels, the lower and softer it becomes. The light we receive from the edge of the observable universe is that echo, stretched, quieted, but still carrying every detail of its original note. Even as it bends and stretches, light remains faithful to its nature. It never forgets its origin. Each photon, whether from a nearby lamp or a galaxy halfway across the universe, carries within it a record of its creation. This is what makes astronomy so unique among the sciences. To look through a telescope is to look through time. Every image is a time capsule. When we observe a star 10,000 light years away, we see it as it was 10,000 years ago. When we capture a galaxy, a billion light years distant, we are witnessing a moment that happened a billion years before we were born. The night sky, then, is not a window into the present. It is an archive. Every point of light above you is an entry in the universe's diary, written in the language of photons, and here is the astonishing part. While to us, this seems like an immense journey across billions of years, for those photons it was instantaneous. From their own frame of reference, the moment of departure and the moment of arrival are one and the same. It's a strange paradox. We use light to measure time, yet light itself knows none. We rely on it to tell us how old things are, even though it is ageless. When you think of it that way, the act of looking at the stars becomes something deeper, almost spiritual. You are not merely seeing distant suns. You are touching the timeless. You are receiving messengers that have never aged, bearing memories that have never faded. Every photon that reaches your eyes tonight has traveled a story that, from your point of view, took eons. But for that photon, it was a single, eternal now. So as galaxies continued to form and collide, as clusters assembled and voids widened, light wove their histories together. It passed from one era to the next, threading every cosmic event into a single, unbroken fabric, a bridge of radiance linking all of time into one continuous present. Even now, every photon you encounter, whether it comes from the sun, a nearby candle, or a distant galaxy, follows those same timeless laws. Light doesn't get tired, it doesn't slow down. It never forgets its origin. Once created, it simply moves on, obeying one rule perfectly. It always travels at the same cosmic speed limit, the speed of light. If you stand in sunlight, you're being touched by photons that began their journey 8 minutes earlier, released from the sun's surface, after spending thousands of years working their way from its fiery core. If you light a candle, the gentle glow that fills your room is made of countless photons racing outward, bouncing off the walls, the furniture, your skin, each one completing its journey the moment it begins. Even the faintest light from a star so far away that its name has been forgotten travels through space without ever losing that essential character. The universe may expand, gravity may bend its path, but light remains true to its nature, a wave that moves endlessly forward, a particle that experiences no forward motion in time. It's almost poetic to realize that when light leaves its source, it has already reached its destination, because for the photon, there is no in-between, there is no waiting, no anticipation, no duration at all. You, on the other hand, exist inside time. Seconds pass for you. Days begin and end. The clock ticks. Your body changes. Thoughts unfold in sequence. But for the photon, this tiny carrier of energy and information, the concept of sequence does not apply. That difference is what makes light such a profound teacher. It shows us the contrast between timelessness and temporality, between being in the flow of time and being outside it entirely. When you look at sunlight filtering through leaves, you are watching an event stretched across space and time. The photons you see left the sun minutes ago, but they touch you now. For them, no time has passed. For you, those minutes have unfolded as part of your living experience. This is why relativity feels so strange. It reveals that time and space are not universal backdrops, but flexible, intertwined dimensions that change depending on perspective. To us, time flows forward. To light, there is no flow at all, only existence. If you could somehow see through the photon's perspective, which, strictly speaking, physics says you cannot, because no rest frame exists at light speed, everything would collapse into a single point. All distances would shrink to zero, all moments would merge into one. From that impossible vantage, the entire universe would be simultaneous. Birth and death, past and future, cause and effect, all would be one continuous whole. It's humbling to imagine that every ray of sunlight, every flicker of a lamp, every glimmer from a distant galaxy is, in its own nature, experiencing exactly that. And yet, though light is timeless, it lets us measure time. Its speed, constant, unwavering, defines our very understanding of seconds, meters, and motion. Without light's consistency, there would be no GPS, no communication across space, no sense of cosmic scale. We owe our calendars and our maps to something that doesn't experience time at all. Even more beautifully, it means that the same rules governing light in your room are the ones that rule the distant quasars at the edge of the observable universe. Every photon, from a spark on your fingertip to a gamma ray bursting from a dying star, plays by the same laws. In that unity lies something quietly magnificent. Across all of space and all of history, the universe speaks one unbroken language, the language of light. The photons that left the first stars billions of years ago are still whispering that language, still traveling, still telling their story without aging a single moment. Every sunrise is their retelling, the universe's daily reminder that while everything else changes, light remains the same, and perhaps that's why we find it so comforting. Even as time moves relentlessly forward for us, light's constancy offers a kind of anchor, a steady rhythm that connects all moments into one. When you turn off the lamp tonight, and the last gleam fades from the room, those photons won't die. They'll scatter, reflect, and continue onward, silent travelers on their way to new destinations, carrying with them the faint memory of where they began. To them, their journey is over before it starts. To us, it continues forever. And so, in the story of light, we uncover the story of time itself. A strange and beautiful reflection of how the universe remembers and forgets. Every photon is born, travels, and ends its journey without ever experiencing the distance between those two moments. It is both a messenger and a mirror, carrying the image of its source, unchanged, across billions of years. Through light, we see not only the cosmos, but the shape of time made visible. The galaxies, the stars, the cosmic background, all of them are portraits painted in motionless time, captured in the glow that reaches us. For us, time flows like a river. We feel its current constantly. But light, existing outside that flow, hovers like a bridge above it. It connects every moment without being touched by any of them. That bridge allows us to look backward through ages we can't otherwise reach. When we study the faint microwave whisper that fills the sky, we are listening to the first breath of the universe. When we observe a distant galaxy, we see it as it was before Earth even existed. Each observation is not merely looking outward, but also looking inward, toward our own place in the grand timeline of everything. Light gives us a language to understand, both eternity and impermanence. It shows us that while nothing material can outrun decay, there exists something that endures, not because it resists time, but because it lives beyond it. And yet, in every moment we encounter light, we experience it within time. The warmth on your hand, the glint in someone's eye, the dawn spilling through the window, all are timeless events translated into human experience. That is what makes our relationship with light so profound. We are creatures bound by seconds, but the universe allows us to touch what has none. When you step outside at night and lift your eyes to the stars, you're not only gazing at ancient light, you're participating in the same timeless exchange that has existed since the beginning. The photons striking your eyes may have left their stars before humanity's ancestors learned to walk upright. Yet they arrive now fresh and unchanged, as though creation itself is speaking directly to you. In a sense, every night, sky is a message in motionless form. A quiet statement that the past still exists, that time doesn't erase, it only unfolds. Light teaches us that nothing truly vanishes. It simply transforms. Even as it spreads and fades, it leaves traces, reflections, echoes, impressions, subtle but enduring. The universe writes its autobiography in photons. Each one is a syllable of its long, unending poem. And through that poem, we begin to grasp our own place in the rhythm. Small, fleeting, but connected to everything. It's humbling to realize that the light you see tonight has traveled across unimaginable distances, through expanding space and bending gravity, to end its journey in your eyes. And in doing so, it completes a story that began before you existed and will continue long after. In that meeting, between your moment and its eternity, something quietly miraculous happens. Awareness. That awareness is what transforms observation into wonder, data into meaning, existence into experience. So as you listen now, maybe take one slow breath, let your eyes close. Picture that lone photon, born in the fire of a star, traveling through the ages, never aging, never stopping, finding its way to you right now, in this single instant of awareness. For it, the entire universe has happened all at once. For you, it unfolds second by second. And somewhere between those two realities, between time and timelessness, lies the space where understanding begins. This is the story of light, and this is the story of time. Intertwined, eternal, and still unfolding. Thank you for watching, and for sharing this quiet journey across the cosmos. If this calm exploration brought you peace, consider subscribing to Science Reshaped, where every story is another step into the beauty of existence. Until next time, keep wondering, and let the light guide you home.